Hello everyone, this is your junior high school math teacher, and in this video I'm going to discuss fourth quarter week number 1 lesson, which is about the application of trigonometry, which is titled right triangles. Actually, how to solve such right triangles. After watching the video, you should be able to solve right triangles and solve related word problems. In this material, you shall be able to apply the principles of solving right triangles in trigonometry in order to solve related word problems such as angles of depression and elevation and some angular directions such as bearings and courses. So suppose we have a right triangle here which is named as triangle ABC. We assume that alpha be the angle at vertex point A, while beta be an angle at vertex point B, and gamma be the angle at vertex point C. The lengths of the sides of opposite angles alpha, beta, and gamma are denoted by small letters A, B, and C respectively. Okay. And angle alpha and angle beta are the complementary acute angles. Okay. And gamma is the right angle, as you can see right now from this drawing. So also, side small letter C is the hypotenuse of this right triangle. Using the definition of 6 trigonometric functions, we have the following. Sine alpha, which is the same as cosine beta, is equal to A over C. Next, cosine alpha, which is equal to sine beta, is equal to B over C. Tangent alpha, which is equal to cotangent beta, is equal to the ratio A over B. Cosecant alpha, which is equal to secant beta, is equal to C over A. Secant alpha, which is equal to cosecant beta, is equal to C over B. And finally, cotangent alpha, which is equal to cotangent beta, or tangent beta rather, is equal to B over A. Okay, next slide. We have now the first illustrative example. Solve the given triangle with the given angle beta, which measures 30 degrees, and side small letter A, which has a length of 24 units. Now this is the triangle, and we labeled those vertices with capital letters A, B, and C. So obviously we call this a right triangle ABC, which is right angled at point C. And we label those given parts. This one right here, the smaller acute angle, which is 30 degrees. So this is your beta. And the other acute angle is labeled as alpha, which at this point we don't know the measure of this triangle. And angle gamma, which is obviously the right angle, together with the labeled known and two unknown sides. Okay, so basically we are trying to solve this right triangle, meaning we need to find the measure of those three unknown parts given that the other two parts. So for our solution, so let us look first for the length of the shorter leg, which is denoted by small letter B. Now to find such leg, we use tangent of beta is equal to side small letter B over A. And we substitute the given parts from to this equation. So, or you transform this equation, we have beta is equal to a multiplied by tangent of beta, and then substitute the known parts from to this equation. So b is equal to 24, which is the value of side small letter a, then tangent of beta, which is actually 30 degrees. Now, recall about the functions of special angles, particularly the value of tangent 30 degrees. Replace it by its equivalent. So we have 24 is equal to square root of 3 over 3, which is your tangent 30 degrees. And then let us simplify this one. So the value, which is the length for side small letter b, is actually 8 square root of 3. Okay. Next, to get the other unknown parts, particularly what? Okay, the measure of angle alpha. So this is the solution. Since the two acute angles alpha and beta are complementary, then we can get the measure of angle alpha by subtracting the measure of angle beta from 90 degrees. And that will give us 90 minus 30 is equal to 60 degrees, which is now the measure of your angle alpha. Okay? Next, for the remaining unknown part, so, which is the hypotenuse, so we use this trigonometric function, cosecant alpha is equal to c over a. Then from here, we transform this equation solving for alpha. Okay. Teka. Oh, no. Solving for alpha. I mean, solving for side small letter c, okay, which is the hypotenuse. I stand it correct. So that is side small letter a multiplied by the cosecant of alpha. Then substitute the known parts to this equation. So that is 24 cosecant 60 degrees. We know that cosecant 60 degrees has a special value, and that is 2 square root of 3 over 3, then multiplied by the length of side small letter a, 24. Then simplify the result, it will give us now 16 square root of 3, which is the length of this hypotenuse denoted by small letter c. Okay? Next. Yun. This one. Next. Example number 2. Find the unknown parts of right triangle ABC given probably this is the length of the hypotenuse, 5 square root of 2, and the length of one leg is 5. So this is the right triangle. And of course, this is labeled as triangle ABC, and let us label the known parts to this triangle. So the vertical leg is 5, and the hypotenuse is 5 square root of 2 denoted by small letter c, and the unknown parts are the horizontal leg denoted by side small letter c, and the two acute angles denoted by alpha and beta. Now for our solution, we solve for side small letter a using the Pythagorean theorem. So that is using the formula a squared plus b squared equals c squared. So plug in the given value. So we have a squared is equal to 5 squared. A squared plus 5 squared equals the quantity 5 square root of 2 squared. And isolating a squared, so transpose 5 squared to the right, that will give you 50 minus this one, which is 25. Or rather, this is your 50 and 5 squared is actually this one, minus 25, because we transpose this term from left going to the right, and that is your minus 25. And 50 here is this one. Then you get the difference on the right side. So a squared is equal to 25. Then you get the square root of both sides from this equation. So you will have a is equal to 5. Okay? Now let us now go to the remaining unknown parts. Particularly the measure of angle alpha. So we use this trigonometric function. Secant alpha is equal to C over B. And that will give you, okay, for alpha, uh, that will now becomes equal to arc secant of C over B. Okay, so arc secant of 5 square root of 2 over 5, that will give us, okay. So if we're going to simplify inside the argument, that will give us square root of 2. And the arc secant of square root of 2 is actually 45. So the measure of angle alpha is actually 45 degrees. Then, we know that the two acute angle, we know that the two acute angles in any right triangles are always complementary. Now, to get the measure of angle beta, you just simply use this equation. Beta is equal to 90 minus the given measure angle alpha, which is 45 degrees. So, you get their difference. We have 45 degrees, which is also the measure of angle beta. Okay, so there you have it. These are now the three unknown parts we have just uh, determined their values. Okay, next. Now we go to the next part of this topic. Now we talk about the two angles. First one is the angle of elevation. Then later on, I'm going to discuss about the angle of depression. Now let us take this angle first. So, an acute angle which is formed by a horizontal line and an observer's line of sight to any object above the horizontal is called the angle of elevation. Now, for you to fully understand the definition of such angle, let us have the diagram or the illustration. Suppose we have this eye of an observer, and okay, so that is the observer. Then he or she is staring at a certain object, like this one. So what you see right now is the eye of the observer staring at the object. So this one here is the line of sight together with the horizontal. And as you can see from this diagram, we have an angle, an acute angle. In this angle right there is the one we are considering the angle of elevation. Okay, the opening of an angle formed by the line of sight and the horizontal. Okay, so angle of elevation simply because this is an angle formed by the line of sight with the horizontal, and the object being observed here is above the horizontal line, as what is stated from the definition of angle of elevation. Okay, yes, this is the horizontal. So again, you must take note that when we talk about the angle of elevation, our reference here is the horizontal line, not the vertical line. Okay? Yeah. Next. Okay, so that is your angle of elevation. Then, let us consider another angle, and this time it's the angle of depression. Now, it is defined as an acute angle which is formed by a horizontal line and an observer's line of sight to any object below the horizontal. So, again, this is the observer's eyes. Then, this is the line of sight which goes down. Therefore, the object being observed here is right here, no? And of course, we have the horizontal line. And just like the first angle, we saw another angle here. Okay? Because this is the opening, this is the horizontal. Then the line of sight, as you can see here, is now below the horizontal, which makes this angle an angle of depression. Okay? Yeah. Okay? Going down, line of sight, then horizontal, and obviously we call it the angle of depression. Okay? Next. let us go directly to some examples. A helicopter hovers 250 meters directly above a small island that is off the Cavite coast. From the helicopter, the pilot takes a sighting to a point P directly ashore on the mainland at water's edge. If the angle of depression is 30 degrees, how far off the coast is the island? Now, for our solution, let us analyze the problem. Okay, so we simply draw a right triangle. Now, in one vertex, this is where the mainland being mentioned from the problem, and on the other vertex, having the other acute angle. So this is where the helicopter is located. Okay, and the vertex at the right angle is what? The island. Okay, now, so what is being asked from this problem is the distance between these two, the island and the mainland. Okay, so then for the angle of depression, which is from the observer of the helicopter, which has a sighting on the mainland. Okay, so therefore the 30-degree angle of depression is right here, the line of sight, and the blue broken line is the horizontal, which is, according to the problem is 30 degrees. So meaning to say, if this is your 30 degrees, it follows that the angle right here is also 30 degrees. Why? Now, if you recall your mathematics in your previous year, which is the principles of parallelism, okay, this broken line here is parallel to this line denoted by x. And we know that if these two are parallel and they are cut by a transversal, which happens to be the line of sight, it means that these two are the alternate interior angles and they are congruent. Okay? Now, of course, according to the problem, the elevation of the helicopter is 250 meters directly below this island. Okay? The small island. So with those given parts from this right triangle, we can now solve for x by using what? The cotangent of 30 degrees. 30 degrees. Why cotangent? Because that is adjacent over the opposite. So that is x over 250. And from here, we can solve for x, which is now equal to what? 250 times the value of cotangent 30 degrees. And what is cotangent of 30 degrees? That is actually square root of 3, which is now the value of x. Therefore, x which denotes the distance between the coast and the island, the mainland, is 250 square root of 3. So what is the unit? I think it's meters. Okay? Yeah. Next. Number 2. From a window 10 meters above the level ground, the building, which is 40 meters high and a distance 75 meters from the window, is observed. Letter A, we are asked to find the angle of the elevation from the window to the top of the building. And letter B, find the angle of depression from the window to the base of the building. So to analyze the problem, let us have the drawing. This one. So this is the building, and from this building we have a window which is 10 meters above the ground level. Now there is an observer from this window, and he sighted the other building wherein he observed that the building is 40 meters high. Okay, and the distance between the two buildings, wherein one of those buildings is where the observer is located, no? And the two buildings are 75 meters apart. So from the problem, we're going to find out the angle of elevation of the top of this building and also the angle of depression of the base of the same building. Now, as you can see from the drawing, that we have broken lines here forming two adjacent right triangles. So let us take one right triangle at a time, particularly the upper right triangle, wherein there is one acute angle here which denotes theta, and this is what we're looking for, the angle of elevation. Okay, so let theta be the angle of elevation to the top of the building. Then with that, to get the value of theta, let us use tangent theta is equal to the opposite leg over the adjacent leg. So that will give you 30 over 75. So if we're going to simplify 30 over 75, that will give us 2 feet. And from that equation, we have theta is equal to the arctangent of 2 over 5. Now, using your scientific calculator, the value of theta is 21.8 degrees. So this is the answer. So this is the angle of elevation, okay, of the top of the building. Now, for the angle of depression, okay, so if we're going to convert this measure in terms of degrees in minutes, that will give you 21 degrees and 48 minutes. Next, letter B, the angle of depression, then denoted by this symbol. Okay, let's just assume that this is P. Okay, so let P be the angle of depression. I don't know, I'm not so sure about the symbol if that is P, but let us uh, assume that this symbol is P. So again, let P be the angle of depression to the base of the building. So the trigonometric function that we can consider here is also tangent of P, which is the opposite leg over the adjacent leg. So that is 10 over 75. Simplify, that will give you 2 over 15. Therefore, P is the arctangent of 2 over 15. And also using your scientific calculator, P is actually 7.59 degrees. Or that is 7 degrees and 36 minutes. Okay? Next. Example number 3, a ladder 42 decimeter long is placed so that it will reach a window 21 square root of 2 decimeter high on one side of a pathway. If it is turned over, its foot, with its foot being held in position, it will reach a window 21 decimeter high on the other side of the path. Find the angles of elevation made by the ladder with the windows. How wide is the pathway from one window to the other window? Now, to analyze the problem, so this is the illustration, okay, being described from this problem, okay? So, as you can see, we have two right triangles. Now, the problem is asking for the angles of these two, denoted by theta and P, okay? And of course, how wide is the pathway? So, the width of the pathway is simply the sum of the lengths of the two horizontal leg of the two triangles, denoted by x sub 1 and x sub 2, okay? So, for our solution, let P be the angle of elevation of the window that is reached by the ladder at the height of 21 square root of 2, this one. So, sine P is equal to what? 21 square root of 2 over 42, or that is, of course, for P, that is the arc sine of square root of 2 over 2, if you're going to simplify this, which is, you will notice, is a special value. Okay, so if we get the arcsine of that value, it will give us a special angle. And what do you think is that special angle? It's actually 45 degrees. Okay, so this is the angle of elevation denoted by P. What about the other angle of elevation denoted by theta? So here we consider the other right triangle. This is your opposite leg hypotenuse. So we have sine theta is equal to 21/42, or that is 1 half. So to get theta, that is arcsine of 1 half, and we know that is equal to what? 30 degrees. So therefore your theta is 30 degrees. Okay, now for letter C, the width of the pathway is being asked. Okay. So basically, to get the measure of this side, if the two sides are given, we use the Pythagorean theorem. Same thing with this missing side. Since the other two are given, so we use also the Pythagorean theorem. So that will give us the width of the pathway is the sum of the lengths of these two horizontal legs, denoted by x sub 1 and x sub 2. So for the width, that will give us the square root of the quantity 42 minus the square of square root of 21 ah, minus the square of 21 square root of 2. Then you plus that by the value of x sub 2, that is what? The square root of 42 squared minus 21 squared. So if we're going to simplify the left side, it will give us the width of the pathway, which is 21 square root of 2 plus 21 square root of 3 quantity decimeters. Okay, so there you have it. This is the answer.